Welcome to the Simplifying Square Roots Notes video. We're going to be talking about how to simplify square roots that are perfect square roots and that aren't perfect square roots. So up here at the top, you will realize that I have already listed some of them for you. So every number up here is what we call a perfect square, and they have square roots. Then every number down here is the actual square root. So for example, the square root of 25 equals 5. That's how you would read this table. What we're going to be doing is looking for powers of 2 to come out of the square root, because a square root, or a square, is the second power. Think of finding pairs in a game of Go Fish. For example, if you had 2 5s, you could put them down and make a pair. We're looking for things to come outside of the square root box, just like you're looking to get rid of cards in Go Fish. We're going to start with some that are a little bit easier. For example, we want to simplify the square root of 121, which is right here on your perfect squares list. So the square root of 121 is 11. If it helps, this is 11 times 11. So since there's 2 of those, then that just makes an 11 outside the square root. So basically, you need 2 of everything in order to make it come out of the square root. Let's try it on the next one. Now, most people freak out about the next one because it is a fraction, but you just got to focus on one number at a time, so I'm going to focus on the 4 first. Well, square root of 4 is right here. So that's 2 over. Then we have the square root of 25. That's 5. So it's just 2 over 5. And that's it, guys. That's all you have to do. Let's do the third one. This one has a 2 in front, so that 2 that's already in front is going to stay there. And it's going to get multiplied by whatever the square root is. So then I'm doing the square root of 49, which if I go look on my list, the square root of 49 is 7. And 2 times 7 is 14. Make sure you have the 3 of those before I move down. Okay, so for the next 3, you'll notice that the number 80 is not anywhere on my perfect squares list up here. So what that means is I have to break the number down. So for example, I know that 80 is 2 times 40. We called this prime factorization, where you just keep breaking it down. So then 40 is 4 times 10. 4 is 2 times 2. And 10 is 2 times 5. Then I'm going to circle all of the numbers that I still have left. And I recommend that you guys pause and do that as well. Because now I need to look for groups of 2. So I'm looking for pairs to come outside. So for example, right here I have a pair of 2. So what I'm going to do is I'm going to put a 2 outside the square root. And I'm going to cross off those 2 2's that I just used. But wait, I actually have another pair of 2's over here as well. So I'm going to put another 2 out there, like that. And then the only thing I have left inside is the 5. And it doesn't have a pair, so it has to stay in. Then I have 2 times 2 in front right here. So I need to actually do 2 times 2, which equals 4. and then you keep the square root of 5. So you're looking for pairs, just like you are in the game of Go Fish. But it has to be a perfect pair. It can't be more than 2 of them. Let's try the same thing with 108. So I'm not really sure what goes into 108. It's kind of a big number. So I'm just going to start by dividing by 2. I know that half of 100 is 50 and half of 8 is 4. So I have 54. But 54 is still kind of a weird number, and I really don't know what goes into it either. But I know that since it ends in a 4, I can divide by 2 again. Now I'm getting a little bit smaller because I know that 27 is 9 times 3. And then 3 times 3 is 9. So you're going all the way until you can't break up any of these numbers any further, which means I have 2, 2, 3, 3, 3. And I need a perfect pair to come outside. So I'm going to go ahead and draw my square root so I have a place to put anything that's left. Then I've got my perfect pair of 2s here. So that comes out front. And I've got a pair of 3s. But I also have this extra 3 right here that's just kind of left. So it stays on the inside. And then I have to actually multiply this in front, which is going to be 6 square roots of 3. All right, let's try one more. We've got 48 for the last one. 48 divided by 2 is where I'm going to start. Half of 40 is 20. Half of 8 is 4. Then I know that 24 is 4 times 6. You could also do 3 times 8 or 2 times 12. It does not matter. I'm just trying to mix it up a little bit. You're going to get the same numbers in the end anyway. So then I know that 4 is 2 times 2, and 6 is 2 times 3. So I've got a 2, a 2, a 2, a 2, and a 3. You have to circle those numbers so that you know what you've got left. Then for my answer down here, I'm going to go ahead and draw my square root. And I've got a pair of 2s here. So I'm going to put that out front. And I've actually got another pair of 2s here. So I'm going to put that out front. And then this 3 doesn't have a partner, so it gets left on the inside. And then you multiply these 2s together, which is going to be 4 square roots of 3. Now let's talk about how to do it with letters. It's going to be the same idea. This time I have 144, which is on my perfect squares list. The square root of 144 is 12. So that's going to become 12. Then, if I have 4 x's, that's just like that. That gives me 2 pairs. So that's going to be x to the power of 2. And if I do the same thing with the y's, it's like I've got 10. Now you do not have to write this part out, only if it helps you understand it afterwards. We've got 1, 2, 3, 4, 5 pairs, so that's y to the power of 5. The reason why I said you don't have to write that down is because every time you do the square root with these exponents, you're going to get half. Because since you're splitting it up into pairs, you're splitting it in half, basically. So a square root does 1/2 times the exponents. Let's try another one. 324 is not on our perfect squares list. So I'm going to start by dividing it by 4. And that's going to be 81. And then I know that 81 is 9 times 9. Now, I decided not to divide by 2 on this one because it is such a big number. So then I realized that I actually already have a pair of 9s right here. So I'm going to go ahead and put 9 outside and leave the 4 inside. Now, 324 is kind of a big number, so I'm going to divide it by 4 first. It's 4 times 81, and then 4 is 2 times 2, and 81 is 9 times 9, which means I can put a 2 outside and a 9 outside. Then I have 3 A's, which means I have a perfect pair I can put outside, but one of them has to stay inside. Same thing with the B's. I have 7 B's, which means I have 1, 2, 3 pairs, and 1 left inside. All right, last one. I know that I can divide 150 by 10 because it ends in a 0. So it's actually just 10 times 15. And then 10 is 2 times 5. And 15 is 3 times 5. So the only thing I actually have a pair of is 5s. So a 5 gets to go out front. But since the 2 and the 3 have to stay inside, that makes 6. Because 2 times 3 is 6. And I'm going to move this 5 over just a little bit. Then for my M's, if I've got 5 of them, imagine if you were holding 5 of one type of card. That would mean you would have 2 pairs and 1 left over. So M squared goes outside and M to the first stays in. And if I have 6 N's, that means that I have 3 pairs. So N to the third is going to go outside, but it doesn't have to leave any inside since it was perfect pairs.